Today I will see some example of metric space just as a review, because in my previous video I have told you the which of the following be metric space. This type of example actually very important for any competitive exam. So today I will discuss more example, also such a more knowledge that you can solve any question of any exam easily. Okay, let's say our first question. First example, let given x d be a metric space, so that the function d1, where d1 defined as d1 xy equal to square root of dxy, where for all xy in the metric space x, we have to prove this d1 is a metric space on the space x. Here given d1 xy equal to square root of dxy, where for all xy in the metric space x. Obviously d1 xy greater than equal to 0, because here d1 xy equal to square root of dxy, where d is a metric space given. Since d is a metric space, that means d of xy greater than equal to 0. Therefore, their square root also greater than equal to 0. Therefore, first condition of metric space has satisfied. Second condition, consider d1 xy equal to 0. And d1 xy equal to 0 means obviously square root of dxy equal to 0. Okay, and just square both sides, then this implies d of xy equal to 0. And since d is a metric space, so d of xy equal to 0 means x equal to y. Therefore, I have considered d1 xy equal to 0. Then I have got x equal to y. So, second condition of metric space also be satisfied. Third condition. Next, d1 xy equal to square root of d of xy. And since given d be a metric space, so d always satisfy the symmetric property. Therefore, d of xy is equal to d of ys. So this is equal to square root of d of yx, and square root of d of yx means actually d1 yx. Therefore, I have got d1 xy equal to d1 yx also. Therefore, all property of metric space be satisfied. Now we have to prove, is the metric space be satisfied the triangle inequality? d1 xz equal to, obviously this would be square root of d of xz, and if we square both sides, then d1 xz equal to d of xz, and since d be a metric space, so this is satisfy the triangle inequality. So this is less than equal to d of xy plus d of yz. Therefore, we can write this as this is less than equal to d of xy plus d of yz plus 2 square root of d of xy square root of d of yz. We can write this as, means this is less than equal to d of xy square root of d of xy whole square plus square root of d of yz whole square plus 2 square root of d of xy times square root of d of yz. Okay, and this is less than equal to obviously square root of d of xy plus square root of d of yz whole square. Therefore, here square root of d of xy, obviously square root of d of xy means this is d1 xy, and square root of plus square root of d of yz means obviously d1 yz whole square. Therefore, I have got d1 xz whole square less than equal to d1 xy plus d1 yz whole square. Here square both sides. By this equation we can write, if we remove the square, then d1 xz would be less than equal to d1 xy plus d1 yz. Okay? Therefore, by this expression, this implies obviously d1 satisfy the triangle inequality also. Therefore, obviously d1, which is defined square root of d of xy, obviously this be a metric space. I hope my all viewers have understood this is clearly. Okay? Well, I will say one interesting question, which is very easy question but very conceptual, and which had come CSIR NET December 2019 exam. The question is XDBA compact matrix space and TBA mapping, which is defined from x to x, which be a continuous function and satisfying infimum n belongs to natural number, distance between tnx comma tny not equal to 0, and this is true for all xy belongs to x with the condition x not equal to y. Then which of the following statements are true? Option 1, t is a 1-1 function. Option 2, t is not 1-1 function. Option 3, image of t is closed in the metric space X. And option 4 indicate if the metric space is a finite, then that implies t is onto. At first, just think oneself, then see my video. Let's see the solution. What is the solution? Here the condition for all xy belongs to x with the condition x not equal to y, infimum distance where n belongs to natural number d of tnx comma tny not equal to 0, and this is true for every k belongs to natural number. Then obviously distance between tkx comma tky always greater than equal to infimum distance of d of t of nx comma t of ny where n belongs to natural number, and this relation is true because this is the infimum distance. So this infimum distance always would be small, so this part always would be greater than this infimum distance, and when k equal to 1, then this imply d of tx comma t of y greater than equal to this infimum distance, which is not equal to 0. That imply from this relation d of t of x comma t of y greater than 0, strictly greater than 0. Therefore, since here x belongs to x with x not equal to y, and here I have got distance between t of x and t of y strictly greater than 0, that imply t of x not equal to t of y. So, since x not equal to y imply t of x not equal to t of y, that means obviously t is 1-1. I hope my all viewers have understood, and this is true only for the property of metric space, because metric space, first property of metric space, always distance function is strictly greater than 0, and since strictly greater than 0, that means t of x not equal to t of y. Also in the question has given x not equal to y, that means this is the, for this property this is the 1-1 function, that means option 1 is the right option, t is 1-1 function. Option 2 is not right, here given it is not 1-1 function, this is not right. Option 3 imply image of T is closed in the metric space X. Here given X to be a compact metric space. Given T is a continuous function, and we all of us know continuous image of a compact set always be compact. Since given X to be a compact metric space and T is continuous, that means obviously their image would be compact. So T of X would be closed and bounded. So image of T is closed in X. This is obviously right option. And option 4 indicate if X is a finite, then T is onto. If X is a finite set, and since here I have got T is 1-1 map from X to itself, and we all of us know since the given set X is finite and T is 1-1 map, that imply obviously T is onto. And this is true, obviously T is onto, because here given the space X is finite. When X is finite, then any 1-1 map always be onto. We all of us know this result. So option 4 also right option. If X is a finite set, then T is onto. I hope my all viewers have understood this question easily. Okay? Oh, yeah. So another example. This is very easy example, just as a exercise. The last example is let XD be a metric space. Then which of the following are not in general metric on the metric space XD? Option 1, rho xy equal to dxy whole square. Option 2, rho xy equal to square root of d of xy. Option 3, rho xy equal to minimum of the set d of xy and 1. Option 4, rho xy equal to 0 when d of xy equal to 0, and 1 if d of xy equal to 0. Here the question, which of the following are not in general metric space? At first notice, I have defined this few minutes ago. This is obviously metric space, so this is wrong option. And this is the discrete metric, so obviously this is metric space. Now see first option, rho xy equal to dxy whole square. All property of metric space would be satisfied because D be a metric space. Just only verify the triangle inequality. For triangle inequality, consider one particular example. Let x equal to 1, y equal to 2 and z equal to 3. Then obviously rho of xy equal to 1, rho of yz equal to 1 and rho of xz equal to 4. Then rho of xy plus rho of yz what? 1 plus 1 equal to 2. But rho of xz equal to 4, which is obviously greater than rho of xy plus rho of yz. Therefore, triangle inequality has broken here. So, obviously, when rho of xy equal to d of xy whole square, this is not be metric space. That means only option 1 is a right option, because in the question has indicated which of the following are not be a metric space on the space X. Option 3 also be metric space, which I have defined in my previous video. A minimum of d of xy comma 1, this is satisfy all property of metric space. This concept I have defined in my previous video. If you don't see my previous video, at first see my previous video, see the playlist of my channel. Then, because this type of example actually very important, this is the metric space. But if they are not indicate not minimum, if maximum be indicate, then obviously this row not be metric space. I hope my all viewers have understood. So only option 1 is the right option, because here the question has indicate which of the following not be metric space on the space X. Okay? Oh well. I will stop here. In my next video, I will discuss different type of question on this topic, because actually this type of knowledge very important for higher study. Okay, see you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.